Hello, my name is Szymon. I work for IS Wireless as a product engineer, and today we are going to explore the theoretical background of one of the main technologies widely used in the telecommunication engineering, which is MIMO. Let's start with the problem technology has to solve. While transmitting the signal, complex factors can occur which influence the quality of the data transfer. Among them, we can list non-line of sight environment, core channel interferences, dispersion effects in time and frequency domains, path loss. On top of these issues, the limited availability of bandwidth poses a challenge for the engineers while designing a system that provides higher spectral efficiency and higher quality of the connectivity with the maintenance of the low cost. Here, one of the solutions is application of MIMO. MIMO stands for multiple input and multiple output. It's an effective antenna technology widely used in the wireless standards to enhance the performance of a single data signal. The wireless standards which utilize it are, for example, WiMAX, 4G LTE, or Wi-Fi. The goal of why do we have MIMO is to provide an improvement to the signal transmission and performance. Even though technology adds complexity to the antenna creation, it assures significant enhancements in the spectral efficiency. Now we'll look into the configurations of MIMO. Each of them has different advantages and disadvantages. Consequently, network designers can choose accordingly to their needs. The first and the most basic radio link is called single input, single output. Here, the receiver and transmitter include only one antenna. This model is used in GSM systems, satellite or CDMA. The advantage of the following system is simplicity, while the disadvantage is high susceptibility to the interferences and fading. Then we have single input, multiple output. This model is characterized by the transmitter equipped with one antenna and multiple antennas on the receiver side. It is often used to enable a receiver system that receives signals from the several independent sources to overcome the effects of fading. This technology is used in mobile communication, digital television, or wireless local area networks. This is also known as receive diversity. Multiple input, single output. In this model, data is sent via multiple transmitter antennas on the one antenna on the receiver side. This MISO is also termed transmit diversity. And then finally, MIMO. Solution utilize many antennas on the transmitter and receiver sides. This system provides the highest possible data throughput and the most robust radio link with the utilization of the different modes. However, the quality of the connection is a trade-off. MIMO systems require the highest computation power, what significantly influences the cost. Now we'll discuss the MIMO block model. Let's begin with the channel coding and modulation block, where modulated bits go to the MIMO transmitter. Here, the transmitter puts the bits into the M number of antennas. Then on the second side, we have the MIMO receiver with the N number of antennas. In the last step, we have the demodulation and channel decoding process. MIMO model has in total N multiplied by M channels, where each of the channels has different signal fluctuations over time, like phase and amplification. As in MIMO, we create multiple independent links that we can use techniques like space diversity, spatial multiplexing, beamforming, or multi-user MIMO. Let's begin with space diversity. The main purpose of this technique is to make the transmission more robust, not to increase data. Instead of sending only one copy of the signal, the multiple copies of the same message are being sent across independently fading channels. In spatial multiplexing, each of the spatial channels carries independent information, thereby increasing the data rate of the system. This can be compared to the orthogonal frequency division multiplexing technique, where different frequency subchannels carry different parts of the modulated data. But in the spatial multiplexing, if the scattering by the environment is rich enough, several independent sub-channels are created in the same allocated bandwidth. Thus, the multiplication gain comes with no additional cost on bandwidth or power. In the third option, beamforming helps to avoid the reception of the interferer signal by directing the beam directly towards the UE. Consequently, the reception is focused towards the desired user. The advantage of formed beams are increased coverage and decreased interference. Antennas that support multi-user MIMO have the ability to connect with the multiple devices with the utilization of the same time and frequency resources. This means when it's transmitting to a smartphone using one antenna, any of the other unused antennas can transmit to other devices at the same time, with benefit by increased number of served users. If you want to learn more about MIMO, I would like to encourage you to see our LTE fileup that allows you to modulate various MIMO models like single input, single output, or the number of the receiving and transmitting antennas. The simulation results can give you the analysis of the signal in the time and frequency domains. And that would be all. Thank you very much for listening, and in case of any questions about MIMO or our LTE fileup, I encourage you to contact IS Wireless. Thank you very much.